Hi everyone, it's Mrs. Summer here to talk about lesson 402, interpreting data displays. This is our last lesson of the quarter. Yay! In this lesson, students will be able to interpret information from dot plots, histograms, and box and whisker plots. So how do we describe distributions? Well, one way is to say it is skewed left. Oops. With skewed left, the tail is all the way at the end over here. The tail of the graph extends to the left, and most of the data is on the right. With a symmetric graph, the data on the right of the distribution are approximately a mirror image of the data on the left of the distribution. If the data is considered to be skewed right, the tail of the graph extends to the right, and most of the data is on the left. If we're describing distributions on a box and whiskers plot, we still use skewed left, symmetric, and skewed right. But what it looks like, a skewed left looks like this. The left whisker is longer than the right whisker, and most of the data is on the right side of the plot. For a symmetric box and whisker plot, it looks like this, and it means that the median is in the middle of the plot. The whiskers are about the same length. For a skewed right box and whisker plot, most of the data is on the left side of the plot, and the right whisker is longer than the left whisker. So how do we choose the appropriate measures when discussing data? Well, when a data distribution is symmetric, we use the standard deviation to describe the variation, and we also use the mean to describe the center. So the mean is the average, and we use the mean to describe the center. If the data is skewed, you use the median to describe the center, and you use the 5-number summary to describe the variation. So if you look here, if it is skewed left, the mean is less than the median. If it's a skewed right histogram, the median is smaller than the mean. So in a skewed left, the mean is less than the median, and in a skewed right, the mean is greater than the median. So in this example, tell whether each data display is skewed right, skewed left, or symmetric. Then compare the mean and median using greater than, less than, or equal to. In this first example, it is skewed right. Because it is skewed right, the mean is greater than the median. In the second example, it is symmetrical. By being symmetrical, the mean is equal to the median. So here's another you try. The number of shoes owned are collected and shown in the data displays. Which gender owns more shoes? Explain using the interquartile ranges and the medians. So women own more shoes based on this data. The median for women is 14. So that median right there is 14. While for men, it is 7. And then the interquartile range, or where most of the data lies, is between 12 and 16. But for men, it's between 5 and 10. So this is showing me that most of the data pulled from women is showing that the number of shoes that they own is between 12 and 17. 12 and 17 versus for men, which is 17. Men, which is 5 and 10. So that's where most of the data lies. So I can infer from this graph that women own more shoes. Here's another example. Given each prompt, decide which data display would be best to show the data. First one is the number of students in a marching band. 2 is the favorite sports of students in your class. 3, the distribution of teachers by age. Now, as you can see, The number of students in a marching band would be a box plot. That would probably be the best way to display that data. The favorite sports of students in your class, a dot plot. And then distribution of teacher by age, I think it would be a histogram. Because you can break up in the histogram by age, so 20 to 30 years old, 31 to 40, etc. So that's why I believe that those are the best plots for each of these different situations.